So yeah, my name's Dave Hamill. I work at Oracle, and in particular I'm a product manager, in particular looking after the risk part of Primavera Cloud, Oracle Primavera Cloud.
So, I can go next. I'm Tomasz Korolczyk, and I'm head of integrated project controls systems at Laminar. And I'm basically a civil engineer that then started a career in planning and project controls. I worked in Ohio River bridges in the US, and I was a lead planner in Panama. And then I moved to London some 8 years ago. And since then, I've been either leading teams of PMO and planners or leading implementations of systems like Unifier, OPC, P6, and others.
That's great. No, thanks for those intros, guys. And hey, everybody, it's Josh here from EHAB. So yeah, I'm the founder of EHAB, who is the creator of WeatherWise. Some of you might be users already, but we are a weather risk management platform that integrates into lots of different tools, including OPC, and really try to help planners and schedulers understand and model weather risk in a more data-driven and science-based way. So we really appreciate you all joining us today. What we're going to do today, folks, is we're going to run through a little bit of a demo. We're going to talk through some of our best practices, and what we really encourage you to do is ask questions in the chat. And actually, what Thomas will be doing is sharing some polls with you as we go. So trying to make the session a little bit more interactive. I'm going to go ahead and share my screen, but bear in mind the session is going to be recorded. So we'll send it to you afterwards as well. So don't worry too much about taking lots and lots of notes. I'm sure some of you will be. But please feel free to ask questions in the chat. And yeah, Thomas, Dave, feel free to fire them at me, and then I'll do the same to you as we're going through as well. So
we'll do. A little technical issue from my side, Josh. What we've tested earlier today, I don't have the Polly option to run any polls. I don't know if there is something you can do on your side, but it's exactly as you said. I'm here to provide a healthy dose of skepticism to what you guys will be sharing, and to ask all of the difficult questions that people, that all the attendants would like to ask you. So I also have my eyes on the chat and bring up the questions, the best of the questions, to your attention.
Yes, and don't pull any punches, Thomas. We're okay with it, aren't we, Dave? I've just added Polly to the top. Can you see it now?
That's it, yeah.
Great. So let me share my screen, and I will just run through a couple slides before we kind of kick into the demonstration. So again, welcome everybody. We're really focused on taking action today. You've just heard from all of us, but myself, Josh, Dave, and Thomas, we're going to be presenting today, and hopefully giving you some useful insights. We've kind of already covered it, but we're going to kind of go through steps that if you have access to EHAB and Oracle, you can follow along, although we're going to be doing a future session where we're going to actually have a setup where you can fully walk through this. So actually probably best to just keep an eye out for that session, because it requires a little bit more setup. But I, you know, to set the background to all of this, the reason I'm in this game is that weather is getting much, much worse. We all have seen it, felt it, and so we really need to take a better approach. That's really my angle from all of this, is that we really need to take a better approach to weather risk in construction and indeed all other industries. And it's not just me saying that. The Met Office, many organizations are collecting a huge amount of data, which basically is pointing to the fact that we really need to think about how we model weather risk in schedules in a much better way, because yeah, the extremes are becoming much more extreme. And so we have to understand how this is potentially going to impact end dates, key dates, and delivery. And this is just a few graphs and charts to kind of hopefully not get you too scared, but almost every single graph I see these days is moving in the wrong direction. And so we've done a lot of modeling specific to construction, and kind of, as you can see on the left-hand side here, like asphalt, for example, is probably one of the activities which is having the greatest increase in potential downtime. But we've modeled locations all across the world. Now we have over 250 projects globally, and yeah, there isn't a single place where things are getting particularly better. So it's getting worse in general. What I'm going to be presenting to you today, before I then hand over to Dave to kind of illustrate how we actually embed that into OPC, is WeatherWise. So some of you have probably seen it. You can sign up for free on our website, ehab.co. It is basically the platform that is being used on about 250, as I said, projects globally at the moment to better model weather risk. And what we're trying to do is make it a really simple, easy to follow process. But before I do that, I just wanted to talk through some levels. So this is something that Dave and myself have been kind of presenting and trying to help people understand basically maturity from a weather risk perspective. So we've currently got 5 levels, although Dave, I've got a couple more levels that I want to add to this that I've not told you about yet. But yeah, really, really briefly, level 1 is doing nothing. So this maturity scale is supposed to demonstrate and help you understand where you might be on this scale. So maybe whilst I'm talking, think about which level, and actually I think we're going to have a poll in a second from Thomas to kind of talk through or to ask you guys where you think you are currently on this. So level 1 is doing nothing, and I hope no one is on that is at level 1, but of course it's possible that you basically are just hoping for the best. We're going to go into a little bit more detail on each of these, and Dave, feel free to jump in as I'm talking. Level 2 is what really we see happen quite a lot, and actually I think it's in some standard or recommended practices from the AECE, which is to basically just add additional padding into activities. So this is level 2, and again, this is really common practice. So you might say, okay, well, my concrete is happening in January. I'm going to add some additional time because, of course, concrete in January might be delayed in the location that you're in. Level 3 is using calendars within P6 or Aster or a scheduling software so that you put some sort of determined downtime for your activity. Level 4 is actually using a risk analysis tool. And so this is using, OPC or PRA, for example, to run a quantitative schedule risk analysis and factoring in some weather downtime in there. And then level 5 is kind of where we are driving towards in this presentation, using a really data-driven approach to create probabilistic calendars to run your quantitative schedule risk analysis or QSRA. So each of these levels have, different amounts of things that you have to do to achieve them, but ultimately, as you go up the maturity level, you're going to get an increased accuracy and much more realistic outputs. I don't think we need to talk too much about the advantages and disadvantages of doing nothing. Again, Dave, jump in here, please, as I'm going through if there's anything that you want to add. Clearly, the advantages, though, of padding activities, which is level 2, is that you do actually take some consideration of the risk more than doing nothing. And it's pretty quick, it's intuitive. But I think some of the critical disadvantages is that, and this is what I've seen time and time again, is that it basically relies on gut feel. So you might say, yep, it makes sense to add an additional down day in winter for concrete, but you are, kind of plucking that out of thin air, perhaps, or just relying on past experience, which I hope some of the graphs from earlier demonstrate that that's probably not a good idea anymore. And of course, there's no maybe difference that occurs when you actually move your activity into a different season. So you might have an activity that gets moved for whatever other reason, and suddenly that activity has additional padding that you then have to either remove or perhaps it gets forgotten, and it basically just means that your activities aren't realistic.
Yeah, it's also invisible, right? So you might have someone just going through your activities and just looking at, oh, this is why this one is 4 days where normally it's 3 days. Let me adjust it. Right.
Yeah, absolutely.
Exactly. It's a good point.
We do have a poll, by the way. I think a couple of people managed to respond already. So if you can't, just try to have a look in the chat. I think that there should be the poll should be available there. So it'll be great to have everyone's contributions to that. It looks like so far mostly people say they see the maturity of their organization as level 3, 75% of people, and level 4, 25%.
Yes, we took a poll last time, didn't we, Dave? Or maybe it was the first session we did, and it was it was probably not representative of the average industry, just purely because of the fact that we are, there's a bit of an optimism bias here. People are self-selecting to join this session. I don't know if you wanted to make a further comment on this screen.
I did run actually the first poll, just a test poll, and it seems like no one is here against their will, so that's good too.
Yeah.
So level 3, this is where we actually start to get into practices that I do see quite commonly, which I think is getting into the realm of clearly much better than levels 1 and 2, and that's using calendars in schedule. Often it's a winter working calendar. I was just in Canada for 6 months, and it becomes quite difficult to do work on a construction site if there's several meters of snow that have just fallen. So often there's some sort of shutdown period in the depths of winter. Or in England, it's probably not the snow, it's the rain, which might become a problem if you have earthworks. So you might have an earthwork seasonal calendar. So of course these things can be pretty useful, but what I generally don't see is people using data necessarily to back that up. Of course, the weather data can be quite changeable from mile to mile, even, especially in kind of depending on the topography of your area. Really what this level 3 is about is people making their best assumption and using that calendar to block out time. I don't know, Dave, if you had a comment here.
I was just going to, just add one thing to this piece, Josh. So we were actually looking at, there's an AACEI, what's the word, recommended practice that we were looking at just last week. I think it's 84R13 for anyone who's interested, planning and accounting for adverse weather. And it's, it basically recommends taking this particular approach, level 3. It doesn't go as far as level 4 and level 5, which is a little bit surprising for me to see that. But what it did make clear is if you are doing level 3 to the extent that they spell out, the amount of data gathering and manipulation of that data, and doing this conversion from rainfall in millimeters, for example, to how many times it crosses a threshold for the particular type of activity. It's a huge amount of work that is all getting done offline in spreadsheets, and then making sure that they marry up to the correct calendars on the correct activities. It's just quite a lot of offline processing, right?
And this method is also deterministic, right? You need to say, I'm blocking off those specific days, which, as we all know, might not be the case. When I was working in the US on a Ohio River Bridges project, we had a flooding event that stopped everything for over 3 weeks. And, we couldn't have predicted that it's going to happen exactly on those 3 weeks. And blocking off any 3 weeks really in the calendar wouldn't be, everyone would raise questions to that.
Yeah, absolutely. Well, level 4, this is where we start to get into the realms of much better. So this is where we're still using weather calendars, but we're now moving into the probabilistic world. So again, this would be using a software like OPC or PRA, for example, which some PertMaster, you might have used it before. And the benefit of this is that whatever you input into the calendar, it is running through a Monte Carlo. So depending on the software that you're using, they all have different approaches, and they all actually model it in slightly different ways. But yeah, that ultimately will lead to probably a better output than just your deterministic calendars, as Thomas was just explaining there. So you may include some contingency for flood, especially if you know that the area is in a floodplain or is near by a river which hasn't been known to flood. But of course, as Dave was just saying about level 3, there's still quite a bit of work that has to be done. You have to gather the data, you have to potentially manually convert it depending on the software. And so this can become quite onerous if you are trying to do this on every single QS array you're running, which of course if you want a realistic schedule, you perhaps should be doing, obviously depending on the size of the contract. But what we're going to focus on today and what we're going to run through and hopefully help you understand why this is a good approach is level 5. So it's taking all of the benefits of level 4 using a quantitative schedule risk analysis, but it's also taking a data-driven approach. And I'm going to show you how within the EHAB software, WeatherWise, you can actually do this really simply. So unless there's any further comments, Thomas, Dave, and we can I'll stop sharing my screen and we can see what the poll results are, and then I'll dive into the demo within EHAB to kind of show you how we're structuring things on our side.
Yeah, well, that sounds good. Like poll results stayed as the same as I was just saying. So level 3 maturity is 75%, and level 4. But I think it'll be really interesting to also get an idea of what tools from the ones that you mentioned people are used to. So I'm going to drop another poll here, just exactly about those tools, if I can make that work.
Well, whilst you're doing that, so yeah, please engage with the polls, folks. Really helpful for us to understand a bit more about how you're thinking about things. I'm just going to get up solution. Hopefully you can see my screen again. And so this is WeatherWise. If you visit ehab.co, you can sign up for free. I'll drop a link in the chat a little bit later on if you want to do that. The aim of the software is to make it as easy as possible at the project and organization level to have a business as usual weather risk management process. We really believe that every single company is going to have one of these either today or very, very soon, just because of the fact that weather is becoming such a significant risk, obviously, depending on the type of project you're delivering. I'm going to jump straight into the process that we're going to be showing you today. So if you were running a quantitative schedule risk analysis and you wanted to get to level 5 as easily as possible, as we were just talking about on that maturity framework, you would head over to integrations. And we do actually have schedule integrations. So if you were at level 3 and you just wanted to get the best version of level 3 that you could, we actually do offer a solution for that. And so that means you can plug in a data-driven calendar into P6, for example, which is a decent approach. We're going to focus today on the risk integrations because that is level 5. That is absolutely the best approach that you're going to want to take for probably the largest, most complicated projects. And so what we tried to do on the software is make it as simple as possible for you to go through the steps that are necessary, because we totally understand people probably aren't going to be using this on a daily basis. So we've tried to design it so that if you are just coming back monthly or quarterly, you don't necessarily have to kind of have serious knowledge of the system to be able to get through. So step 1 is selecting a site. And what this does in the software, when I go in here, and I'm just going to pick a site that I've already created, but you can pick a site anywhere on planet Earth. And I'm just going to pick Ottawa, because that's where I just was nearby when I was in Canada. But when I select this project, what it does is it actually creates a data set in the back end of the system with 50 years of historic data. And that is for wind, rain, temperature, snowfall. We're actually just about to launch over 130 variables, actually. So that includes river discharge. That includes soil moisture. It includes wind at heights. It includes 130 variables. So quite a lot of different things that you could now start to model. And that's what step 1 is selecting your site. So straight away, all of the data will be available to you. And that's what some of the other reports on the platform are about, is enabling you to interrogate that information. But the second part of our standard process that we've created is to not think about risk just as weather types. What we actually want to do is think about, well, how do those weather types affect the activities that I'm taking or doing on my site, because multiple weather types will affect activities. And so what we're trying to demonstrate and help you model is rather than, okay, rainfall is going to happen at such and such an amount, because it's actually really difficult to model rainfall. What we want to model is the thresholds at which the activity is impacted. So just using asphalt as an example, and just bear in mind this is in Ottawa, so it's one of the coldest capital cities in the world. If you set your daily minimum temperature at 5 degrees, then you basically will never be able to work in winter, because the system looks at the historic data and it says, okay, on average, on a daily basis during winter, how often is the threshold of minimum daily temperature of 5 degrees broken? Basically 100% of the time in January, but only 38% of the time in May. So what I can do though is change this to -5 if I wished. Maybe I'm applying a mitigation. I'm changing this threshold, and part of the beauty of the system is that we'll then instantly refresh, and it allows me to kind of run these what if scenarios and change the thresholds to match actually the type of activity that you're doing. So although we have lots of defaults in here, you can go ahead and change those. You can completely customize them. They're just based on British standards at the moment, but of course you may be in a different country, or you may just decide that actually these thresholds need to be changed so that they're the most suitable. And this step is really, really important, because actually this is what drives a lot of the results that are going to be happening in your quantitative schedule risk analysis. So, if, for example, you, Thomas, were running a risk workshop with your client, this is where I would suggest that the most time is spent, just because clearly this is what can have an impact on the result. And actually, some of the exercises that we've done with clients in the past is they might have a pre-mitigated, a post-mitigated, and several different sets of risk matrices that they can then do different analysis with, and compare those rules and what those mean. So that's the second step.
That would be my question, because probably I would create different categories for like concrete with anti-freeze, addictive, and a normal concrete, right? Because you're paying for that as well. So that's additional costs. So, to fully model where you're using which type of concrete, where you should be applying those different thresholds, you can just create different categories, right?
Yeah, exactly.
I also had one question about the data set, because you say it's 50 years of historical data, but you also showed on some of the first slides that the change right now, it's much faster, right? That those weather events are much more, maybe not unpredictable, but the scale of that is faster. So are you taking that into account in the data set, that change in the last years? It's not linear basically from the last 50 years.
Yeah, no, I mean, absolutely a great question, and you're right. When the graph is going up in this direction, you need to make sure that you factor that in. So on this screen for the weather rules, it is just purely a historic look back, because what we wanted to create with this screen is just to say, okay, if I change my rule really quickly, give me a rough idea of what the downtime would be. But when we actually create the calendars, and when we push that information as we're about to into the schedule risk analysis, then what we do is we weigh the most recent years in the data set more heavily. And we're actually about to just release a low, medium, high scenario, which would give you, of course, the ability to kind of choose as well. Because let's say you have a 10-year project. Okay, the first 2-3 years probably are all relatively similar, but the spread of a high, medium, low scenario might be much greater in a decade's time, obviously, depending on what the world does. So yeah, you're absolutely right, Thomas. We factor that in once we get to the final stages of this analysis, if that makes sense to you.
Yep.
Well, the step 3 is pretty simple. That's importing a plan. And so this can be from any scheduling software. I'm just going to grab my my plan here. And the final step, once I've imported, would be to assign categories. So what we really recommend is you use activity codes. So in the solution, you can see the drop down here. There's various kind of work codes. You can have your own EHAB codes within the plan that you've already pre-assigned, or you can use existing coding that is already in your schedule. It doesn't really matter. You'll be able to select them here. And as I've done previously already, I selected formwork as formwork, structural steel, as you can see. And then on the right, you can see I've got 6 categories in use, 500 activities that have been assigned. And basically what this means is everything that's been listed as cladding now has the set of rules that is associated to cladding. So when the analysis runs in OPC, as Dave is going to show you in a second, it's going to take the historic data with the climate trend for these thresholds of cladding based on the start and end dates of the different activities that are cladding. And actually the calendar that we give you, which you integrate into OPC, will have information for every single day and every single week, going forward in time, so that when you run your quantitative schedule risk analysis, as Dave is about to show you, you have the most appropriate set of probabilistic data for downtime for each category type. So that's maybe the final key piece of information, is when we export to OPC, which I'll hand over to you in just 2 seconds, Dave. On the screen there's a video, so actually you can follow along, and all you have to do is click generate, and this will give you calendars for each of the types of activities that you've got here. So in this case, 6 different activity types. Is there any questions at that stage, or shall I hand over to Dave? No, Dave, you ready to take it away?
Do you use activity? Those are like P6 or OPC activity codes, right?
Yeah, I think in Microsoft Project they're called something slightly different. But yeah, you can. It works in other solutions as well. Yeah.
In terms of P6, you can use codes or UDFs, right?
Yeah.
Yes.
So those on OPC, those would be called codes or configured fields.
That's right.
In Microsoft Project, whatever else. Yeah, no, that's super useful. We also got some, before you jump to Dave, before we hand over to Dave, we got some results on what QSRA tools people use, and it's I would say 50-50 Oracle and non-Oracle combination. So 30% OPC, 20% PRA. So that's on the Oracle, within the Oracle universe, and then most people responded with Safran, and 10% with Deltek Acumen. So yeah, it looks like we've put good systems to ask about, because at least one person has always used one of the systems, so that's good.
Thanks, Thomas. Just check you see my screen okay now.
Yeah.
So yeah, I think I've been working in risk a long time and involved in weather risk modeling for a long time, but I think the thing that's certainly changed since I kind of been working with Josh and EHAB is this concept, as Josh described, from putting risks in the risk register that are things like rainfall and temperature, to being activity types. And this is an example of the code, for example, that I'm using in this case that Josh was just talking to. So here I've got a schedule, I've got a wind farm. You can see the different activities, the different turbines, and I've got just some coloring on this particular code as well, where I've just classified those activities into these activity types, right? And I'm using some of the existing ones called roofing. I could actually create one that was called blade installation, right? If I was doing this more often and use that, but roofing is pretty close to blade installation for me, so I'm kind of using that as an example. But it's these activity types in effect that match what Josh just had on his screen a moment ago. And then in Primavera Cloud, so I've got the activities page, I've just got the same project, and I've got the risk register in here. So you've got the ability to download and import template, and then import risks, and the output that we get from EHAB is exactly in the format that we need to do the import into Primavera Cloud. So we run through the import here. So Josh took you as far as clicking on the generate risks. We do the import. From a process perspective, there's not too much more to it than that. I've got in this case, the six different categories. I can see for most of these, I've cheated a little bit to save a little bit of time. I've got the impacted activities, which if you've done the mapping as Josh showed you inside of EHAB would be the case. The other option is to get them without the mapping, and you could do that within here as well, right? So if I switch to another view here, where for example I have grouped by these categories instead, I could grab all of my different roofing activities that are next to each other and just say I want to assign to these 12 activities, the risk that's called roofing, right? Would be the other way to approach this.
So if you do that on OPC, and then you export it and you use that on EHAB, all of that assignment would be carried on, right? It will be saved.
That's a good question, Tom. So I'm not actually sure on that perspective. I'm coming at it more from the angle of you wouldn't necessarily have to take your plan to EHAB to begin with. You could just say these are the different categories that are relevant. These are the 6 or 10 or whatever that I'm going to pick. Give the overall time frames of the project. Like it's going to start, January next year and last for 3 years, but you wouldn't need to give the detail of the schedule. And then it would just generate, the 6 risks over a 3-year period, and the mapping between risks and activities you could just do inside of here, or Safran or whatever. I'm sure it does a similar process to this as well, right?
Yeah, no, that makes sense.
Yeah. And I guess, there's I know some customers get a little bit concerned about necessarily taking their schedule out and then bringing it back. You wouldn't have to take your schedule out if that was the case, right? It would just be grab the weather data from EHAB and do the rest inside of Primavera Cloud in this case. So you can see that these weather risks have all been created. So we've got like the different periods, the number of non-working days in each of those periods. We've also got this ability to look at a little calendar. It's just like a quick schematic, a visual of what this looks like. It actually runs a little mini Monte Carlo simulation when we do this, and it takes just a few seconds. So this is, let me skip to next year where we've got a full year's worth of data. So you can see, the much darker periods in Jan, Feb, and December, for example, compared to in the summer months, the percentages of down days, or I can look at an iteration. So this is effectively how, the weather gets taken into account during the Monte Carlo simulation for each iteration. These are additional non-working days that are going to hit your plan based on roofing in this case, right? And you can step through the different iterations, and you can certainly get a feel just stepping through that, how much you're getting impacted by in those winter periods, right?
And what you were showing before was basically an average, like a heat map from all iterations.
Exactly. It was, I think we just run 100 in that first little calendar generation. It's not the full 1,000 or 5,000 or anything. It's just giving you a quick feel for what that looks like. But yeah, it's running a mini Monte Carlo simulation. It's showing you, first of all, the average. Yeah, I think in this particular one that I've gone to, there's very, very little. So there wasn't actually anything in 2025 there. So yeah, this is the average across the simulation. And then this is the individual iterations. And you can see I'm just showing as a contrasting example. This one's got, next to no downtime. So obviously you're going to have very, very little impact on the simulation. Yeah. So otherwise, you're ready to run your simulation. Obviously, I'm focusing just here on weather risk, but your risk register here could have, your threats and opportunities, your typical risks in here as well, which, is a pretty valid point as well, right? One of the things that Josh mentioned is sometimes when you're doing your padding type of approach to estimate how long you might need to add to an activity, it's based on the activity being at a particular point in time, right? Maybe that activity is going to be in June, but if you've got a threat that moves it to December, suddenly the impact of weather is going to be different as well. So it's often you get these, these two different impacts contributing towards each other, right? So I'm going to run a risk analysis. So this is now just running the Monte Carlo simulation. I'm kind of assuming most people on the call are familiar with Monte Carlo simulation, because I wasn't going to go into it in a huge amount of detail, other than to maybe look at some of the outputs in a second. So I get a little notification up at the top here to show that it is just completed. So maybe I'm jumping a little bit, by my navigation is just, schedule. I get the activities page in the risk app. I can go to the risk register, and I've now just gone to the risk analysis page. I'm just saving a bit of time by having them open in different tabs. And here is where I can see, for example, my deterministic date we display here is an orange line. This is the date in my schedule before I ran risk analysis. And then I can see, the days is a weekend. I'm slipping a week, slipping 2 weeks worth of time in this particular case. So I've got things like my P10, P50, P90. I'm assuming for anyone who's familiar with Monte Carlo simulation, this type of output is fairly familiar, right? And I can see, I probably need to be allowing about 13 days of contingency for weather if I want to have a 90% confidence as to when this is going to finish, right? Any questions on that, Thomas, or others?
Yeah, can you, so these are just weather risks, right? But as you go, you could then have also activity uncertainty, and you could have other non-weather related risks. Would you be able to
absolutely
add all of that?
Yeah. So this, focusing on the weather here, I've just got the weather risks in this example, but this could absolutely have 10, 15, 20 threats and opportunities. I could have activity uncertainty, could all be in here, right? And as I was trying to describe earlier, it's like, you might have a threat that adds 3 months, and it pushes an activity from a time of year when there's not much weather impact to a time of year when suddenly the weather impact is going to be really quite significant, right? Moving into winter in where were you, Josh? I've forgotten. Ottawa. I was about to say Ohio. It wasn't. It was Ottawa. Yeah. Could make quite a significant difference because of the fact you've got your threats and your weather risk, coming together to kind of cause the perfect storm, if you like.
And just to jump in, Dave, I think that's why we say, we're not just saying level 5 is the best because it's the highest number. It's because it has this combination of all of those factors that are getting mixed together, so that it is, it's not over or underestimating those risks. It is, the probabilistic nature of it means that the output is, as accurate as it perhaps could be.
Yep. No, absolutely. And you can look at like the tornado type of output as well, to look at either which activity, or probably in this case more relevant to look at which particular risks are driving it the most. We've got these nice catchy ID numbers on here, which are probably quite meaningless if I stick the name on there as well.
Yes, no taken, Dave. I will make sure to change those codes.
I can see it's my site clearance, followed by my roofing. Not surprisingly, that testing and commissioning, for example, the one that we saw with next to nothing, is having very little impact at all. And the good thing about, once you've got your project in here and you've got your risks updated, it's nice and easy to do some sort of like what if type of stuff as well. So I could take a copy of my existing project that we've just been looking at, and what if it was starting in a different month? So make a copy of this particular project. I'm going to keep all of the schedule and even all of the risks in there, but actually I'm going to push the start of it out to let's say Jan instead. There it is. This is just, nothing else needs to be done other than go straight to the risk analysis and run it, right? I'm going to get it at the activity level also. This just means you can look at any particular milestones at the end too.
Is that not going to take 5 minutes?
5 seconds probably, Thomas. Completed.
That's pretty. That's really fast because you are running it for all activities as well.
Yeah, 1,000 iterations. It's not a particularly massive schedule in this case, but yeah.
True.
But you can see, you know, in this particular case, you know, these are now weeks along the bottom rather than we were days on the previous one, right? You know, we could see this was in days, and this is a week. This is another week, and these are the weekends in here. You can see instead on this other project, you know, it's slipping much further out, right? These are all in weeks. In fact, that contingency out of my P90 that was previously was 13 days, you're now talking 38 days, right? So this is exactly the same project as you've seen. It's exactly the same schedule. It's exactly the same risks in the risk register. It's just starting it at a different time of year. And, you know, you can do some very quick analysis to see how much of a difference it would make delaying or bringing forward the start of a project, right? Based on the impact of weather.
Yeah, and I think that's super important because like you create your baseline and that's your starting point. And if you then model your weather risks in a deterministic way into those activities, and then you start having some delays, none of that is going to apply anymore. So you kind of need to do it either like in calendar way or the probabilistic add them as probabilistic risks, but just adding you know, padding activities, as you guys called it, would be a terrible approach if you have slippages.
Yeah, and I guess Thomas, you also touching on the subject of change as well, and that can be you know, something else that gets pretty complex. But you know, when you're going through change on a project, one of the things that often gets missed as well is that you might be moving activities to, again, a more a time of the year that weather is going to have more of an impact, right? And sometimes it's easy to think, okay, that particular change is going to add these 10 days, but you maybe miss the fact there's another 10 days because of the time of year you're getting pushed into, right? But having an approach like this that's data driven, and I think I think the best thing about EHAB is it makes it nice and easy. I think the second best thing, it's neutral, right? It's not the contractor trying to get one over on the owner or vice versa. You know, it's a data driven source. I think, you know, if it's used, you know, to me, it takes away the arguments between owners and GCs, right?
Yeah, and I actually just realized we have 2 questions, and sorry, because the first one was 18 minutes ago, so obviously I'm not doing a great job on this one. But Abd asked a really good question about how do you integrate weather risk analysis with cost?
Yeah. So basically, that is all just down to how you build a schedule. If I did, if I switch views on here, if I just had an activity that's got resource loading on here instead, I was trying to find if I've got a.
Because on OPC, when you add normal risks, you can have schedule impact and cost impact, right? But I think you can also select that include cost impact from activities, which is like if your activities are resource loaded, and you know we assumed a certain rate, a certain resource for 10 days, but now the duration of that activity grew to 20 days. Like obviously there is an extra cost associated with that extended duration that's coming from your resource utilization. So I know that with other risks, you can account for that on OPC, but with how would that look like with the weather related ones?
Yeah. So the key difference with weather compared to threats and opportunities is, so a threat or an opportunity will change the duration of an activity. Weather risks don't change the working time of an activity, they change the non-working time. So if you model the costs on the activities themselves, like if I was to put a cost on, install blade and put a resource on here, I wouldn't see any additional time, any additional cost, because the working time is still the same. But at any level, even down to mirroring every individual activity, if I want, I can put a resource. As an example, I've just put a summary activity that spans the whole project. In this particular case, it's got a cost of 80,000 just based on the particular resource and the rate that it's got. When you run the scheduler in here, you've got the option to also calculate costs at the same time. So this will just, at the minute, it's just got a default duration of 5 days, assuming I've done this correctly, which is a good chance I haven't, because I'm trying to do it on the fly in the middle of a demo. Okay, so it's got a cost of 6.5 million roughly. It's a relief. And if I now run the risk analysis, I'm in the right one here. Yeah. You've also got this schedule cost. This just means also recalculate the cost at the same time as you go. It's exactly the same as that schedule cost option that you've got when you run the run the scheduler. Just completed. So this distribution is just the same. If I go to my cost picture now instead, so I can see the roughly 6.5 million that it costs deterministically, and I can see the range of cost increase that I'm seeing, all because of weather in this particular case, right? So I can see, at my pessimistic, I'd need, an additional 200,000 in this particular case. Maybe the numbers I've got on here are not great as an example, but, completely winged on the fly. I think it'll hopefully shows the purpose, shows the way that it can be done.
It'll be useful to go back to Toner's question. So that'll be more to you, Josh, about I'm not sure if that's not going to be too specific. Maybe you'll need to park that. But the question was, where are you getting your input rainfall thresholds from? Because they say we can retrieve dew points, mean temperatures, but struggle on rainfall.
Yeah, Declan, it's a really good question, and honestly, probably the problem we're thinking most about at the moment. So how we do it today. We've looked at standards and had expert interviews with different people who have suggested what the thresholds should be for different categories. And of course, those are still can be changed, and we recommend that you review them before you put them through the analysis. But we are doing a piece of research right now because clearly, at the moment, we model things on a daily basis. So if it rains over 10 millimeters of rain in a day, and that's your threshold, then that will be counted as a down day. But what if you have 10 millimeters of rain every day for 5 days? Each of those will be a down day, but would that then mean that you have down days afterwards as well, because your site is now flooded? And of course, whether your site is flooded or not, or waterlogged or not, is obviously dependent on the soil type, the amount of drainage that you can have. So we are building what we're calling a wetness model, which is basically combines soil type and therefore drainage with the preceding, I don't know what we're selecting, but the preceding number of days and what the cumulative rainfall is on any given day. So instead of saying my threshold is 10 mil each day, it might be my cumulative threshold is 10 mil for clay, or 7 mil for what is chalk, or whatever it might be, and we'll create some sort of rough standard. What we're then going to do is try to gather as much data from folks like yourself or whoever else is using the system to try to determine and get a feel for the accuracy of that. Obviously, we'll be taking it based on data that we have, but it's a really difficult problem because it to some extent is dependent on how you are managing your site as well. Obviously, some sites may have installed drainage specifically for this purpose, and others may not have. And so it is a challenge for us as well. But I hope we're trying to build in as much science into the process as possible where we can, and of course we'll evidence all of the research that we're doing on that once we publish it. But hopefully that answers your question.
But just we were talking about the thresholds that you're setting for different categories, right? That you like, maybe that was the second step, I think, in your presentation. Isn't that just an indication of where the threshold could be? I think, you know, you kind of expect users to review if that applies to their site, if that applies to their activities, because it can be different even for different areas of the same project, right?
No, absolutely, and of course, always encouraging, you know, users should not just rely on the defaults. The defaults are a good starting point. You should set your own thresholds. I think I mentioned that research about wetness, because once you start to dig into, well, is it 10 millimeters or is it 5, you then realize that actually there are other factors for rainfall that determine the impact that you're trying to, because, you know, we're not trying to model rain. What we're trying to model is actually the impact that it will that the potential rain will have. And so by giving people a few of these extra effectively levers on how the impact is modeled, it does ultimately result in the impact modeling being more accurate or more true to how it would be at a given site. But you're totally right, Thomas. That would still determine, you know, you still have to then choose what's the soil type and what is the threshold for that soil type, and then how many days impact does a certain amount of rain have? Is it 1 day or is it 2 days? Again, not easy to necessarily determine that, and that is where, you know, users have to use their best judgment to some extent still. Hopefully it made sense there.
I think I'm like trying to understand it. I'm going back to the project in the US and Ohio River Bridges where I was, and you know, I'm thinking construction or activities on site would stop when it's raining, right? When it's a slightly heavier rain, because no one wants to, you know, work in the rain and unless they're inside a vehicle. But then we didn't really build any access roads on that site. Everyone was just driving 4x4, you know, pickup truck. It was very like American way, I must say. But when it was raining for some time, and this cumulative impact of the rain would make the soil so would turn it into mud to the point that even the 4x4 trucks could not get by, and that would cause you know, other set of issues. So in fact, like the same weather condition, rain, can cause two completely different you know, set of consequences.
And it's a great example of how we want to build more sophistication into the system, but also how, you know, there'll always be edge cases that will mean that it's not a, you know, I wish we could perfectly predict weather impact on the schedule in the future, but clearly it's still a best case that we're trying to create.
I think right at the start of this presentation, Josh, we talked about maturity levels. You know, we're trying to improve people's maturity. I think there'll always be room for improvement, even if everyone was at the level 5 as we've got it defined today. You know, the types of things that we're talking about now is further improvements again, isn't it? And I think, you know, just listening to your answers to this, Josh, it's great to hear that there's someone who is actively working right in this area, from my perspective, that it's right in the area of getting relevant data that can be used by scheduling and QSRA products specifically for the construction industry, right? And, you know, just the fact that there's someone out there doing that is brilliant, right? Compared to the alternatives before.
I think that's where a lot of the times when we model weather risk, the issue comes from, like, well, where the data comes from, who's modeling it, right? If is it a client organization or is it a contractor? Were they trying to use the data that is favorable to them? It is, let's account for more or less weather days, and or on the other side, if it's a contractor, they would want to get more weather days into the schedule. So I think having one source of where the data is coming from, that just from the start all parties agree, let's use that. Whatever it shows us saves a lot of the time for everyone.
Exactly, and it's a neutral data source to begin with, and everyone's agreement up front. It just saves all the time out of any ambiguity and discussions about it as well, right? I think the time savings from that perspective as well.
Yeah, and the time savings of, like, if you were trying to do this by yourself, just by retrieving some data from Met Office and then analyzing the last 40 years or so, I mean, that takes so much time. It's I know no planner wants to do that, and it's usually not part of your typical job to do that. So now you're being tasked with something you're not really comfortable with, but and you're not sure if you're doing the right thing, but you can analyze it and you can do it somehow yourself, but it's going to take you a lot of time.
Yeah, absolutely.
Speaking of time, I'm very conscious we are getting to the end of the day and the end of this webinar. So does anyone have any final questions for myself, Dave, Thomas, before we head off? I did have one final one for you, Thomas, which, just going back to what Dave was just presenting about, changing the end date. I was really curious if you kind of anecdotally could kind of speak about how often does this happen? How often does the start date of the program get changed, in reality, at least from your perspective, and then therefore the type of info that this kind of analysis would benefit teams around?
Well, I think the simple answer is all the time, right? All the time. We're at Laminar, we're managing huge portfolios of projects, and even before they start, the start date may be moved into the future. So, but everyone, as at the moment of creating the initial schedule, the optimism bias, everyone thinks, okay, we are going to start on this date. And but yeah, you see that changing all the time.
Dave, any final words, any final comments?
No, not really. I think it's just been a good session again, Josh, and thanks to Thomas for keeping us going with questions, and Polly. It's been good.
Thanks for the invite. I really enjoyed it, and I hope that I represented the questions that people wanted to ask. So yeah, thanks a lot.
Even if slightly delayed.
Yeah. Sorry.
Thanks everybody for your time. Have a great rest of your day. Okay.
Cool. Cheers all. Thank you.
Take care, everyone.
Everybody. Thank you so much. Bye bye.